spacecraft prepares for landing. It has traveled for nearly 9 months, hurtling through more than 500 million kilometers of interplanetary space. Now, as it plunges toward Mars, the robot visitor sheds its protective cocoon. Just 20 meters from the surface, it hovers, then carefully lowers itself on a specially designed hoist. For 16 seconds, the robot's fate hangs by a nylon thread. Then, it touches down, safely, on Martian soil. Its mission has begun. A mission in the name of curiosity.
When NASA was looking for a nickname for its 2012 Mars rover, it could hardly have chosen a better one than Curiosity. 8 years before, its two predecessors, Spirit and Opportunity, had proved that roving vehicles could revolutionize our understanding of the red planet. With Curiosity, rover technology had advanced, and scientists were in the driver's seat.
Those scientists were guided by an ambitious goal. Previous missions had shown that in the distant past, Mars had standing water on its surface. Now, Curiosity would go one step further and try to determine if Mars could once have supported life. That's a more challenging question to answer, and researchers needed a bigger rover to answer it. At 900 kilos, Curiosity is the size of a small car, allowing it to carry 15 times more scientific hardware than previous rovers. It's the most sophisticated suite of instruments ever to land on another planet. And for the Mars program, it's a big shift in approach. Earlier rovers were designed to be like wandering geologists, traveling over the landscape of Mars with a toolkit similar to one that a human astronaut might carry. By comparison, Curiosity is an entire laboratory on wheels. Its equipment includes a laser, capable of zapping rocks up to 6 meters away, in order to read their chemical composition. And its 2-meter-long robot arm carries a camera and a spectrometer for examining the surface up close, as well as a drill for extracting rock samples that can be tested by various experiments inside the rover. This is a planetary explorer like no other. And so is the place it set out to explore. In planning Curiosity's mission, scientists spent years combing through satellite images looking for a landing site that might offer signs of a habitable past on Mars. The search led them here, to Gale Crater. It's 150 kilometers across, with a 5.5 kilometer high mountain rising from its center. Like most craters on Mars, it formed billions of years ago, when an incoming asteroid collided with the planet's surface. The force of the impact blasted a giant hole in the Martian bedrock. A crater on Mars is easy to understand, but a mountain inside a crater is much harder to explain. How could such a towering feature have grown out of a deep basin? Scientists now suspect the answer is that the mountain didn't grow at all. Rather, it was left behind as other material was removed. The theory is that sometime after Gale Crater formed, it was blanketed with dusty sediment. Eventually, layer upon layer of sediment filled the crater to the brim and beyond. Later, wind chiseled that sediment away. It scoured out the crater walls, but left a large mound in the middle. The mound's official name is Aeolus Mons, but NASA scientists have dubbed it Mount Sharp, after Robert Sharp, a pioneer of planetary geology. Mount Sharp is what brings Curiosity to Gale Crater. Scientists hope that by climbing its rocky flanks, the rover will be able to read millions of years' worth of geologic history, laid down one layer at a time. Some of those layers are plainly visible from orbiting satellites. The lowest layers are the oldest. They're of special interest because the data suggest they're made of clay, which means they were likely deposited by water long ago. Moving further up the mountain, other layers may reveal how those watery conditions changed over time. The upper reaches of the mountain appear to be made up of material that was deposited by wind once the planet became dry and dusty. From top to bottom, the mountain seems to present the complete story of Mars. As soon as Curiosity landed, scientists were thrilled. Not only had the rover touched down safely, Mount Sharp was in plain sight. It towered on the horizon in one of Curiosity's first pictures from the surface. But the mountain was 8 kilometers away, and scientists knew it would take the rover more than a year to get there. So before the long trek began, they decided to explore Curiosity's immediate surroundings. It was to be the first test of their new laboratory on Mars. But little did they know just how much that test would reveal. Curiosity set down on the floor of Gale Crater, it became the 7th spacecraft to land successfully on Mars. But more than any of its predecessors, Curiosity was built to journey far beyond its landing site. The rover's main objective was to reach Mount Sharp and study its layered geology. Those layers could already be seen in the distance on the mountain's lower slopes. But before heading in that direction, Curiosity had a chance to visit other points of interest closer to hand. Just a few steps from where Curiosity stood, scientists could see where the rover's descent stage had blasted away loose dust and gravel. The exposed patches showed that the soil was only a few centimeters deep in this part of the crater. Below it lay what looked to scientists like a type of conglomerate rock, a rock made up of smaller pieces cemented together. This was intriguing, but curiosity did not venture any closer, in part to avoid contamination from any lingering traces of rocket exhaust. Instead, scientists now had a different idea. Not far from where Curiosity landed, satellite images showed where a river had once spilled into the crater. The riverbed ended in a fan-shaped deposit, left behind by water spreading sediments out over the crater floor. It was always the plan to try to land near this feature, and now Curiosity was right on the edge of it. By using the satellite imagery as a guide, scientists could see that just a few hundred meters from the landing site lay a point where the river deposit intersected with an older terrain. This looked like a promising spot to learn more about the ancient history of the crater floor, even though going there would mean driving away from Mount Sharp for a time. In the end, the detour would take far longer than scientists expected, but it would eventually lead to a big discovery. As Curiosity began moving over the landscape, it came across clues that pointed to an intriguing past at Gale Crater. There were more examples of the conglomerate rock that had been exposed at the landing site, this time jutting out of the ground like pieces of broken sidewalk. And when the rover zoomed in for a closer look, it found pebbles that looked rounded as though by water. This is typical of what is found in ancient stream beds on Earth. Already, the geologic story emerging from Gale Crater looked like an exciting one, but filling in the details would take time.
As they carefully gathered data, scientists were striving to understand if Mars could have supported life long ago. But given the rover's capabilities, there was also a more immediate question. Could there be something alive on Mars right now? And there was a chance that Curiosity might provide the answer by plucking it out of thin air.
For 10 years, scientists had been tantalized by reports of trace amounts of methane in the Martian atmosphere. The reports were mainly based on observations made from Earth, but the presence of methane was also indirectly confirmed by Mars Express, an orbiting spacecraft run by the European Space Agency. The Earth-based observations show that the methane seemed to be concentrated around particular features on the Martian surface, like these giant gashes called Neely fossae, where spacecraft have also found signs of carbon-bearing minerals. If correct, this was a major find. On Earth, methane gas is produced by living things. It's a telltale sign of biological activity. Methane gas can also be produced chemically, but that requires the right kind of minerals along with water and plenty of heat. Either way, methane would mean that Mars was not a dead world, but a geologically and possibly biologically active one, somewhere below the surface. Now Curiosity was in a position to weigh in on Martian methane. Unlike earlier rovers, it had the technology to directly measure the chemical composition of the atmosphere. Over an 8-month period, that's exactly what the rover did. The result was a surprise. The rover found no significant amounts of methane on Mars. Either the methane reported earlier had completely vanished through some unknown process, or because of a misreading of data, those earlier reports were wrong. This is not the first time Mars has given scientists contradictory evidence related to alien life. But with the methane question out of the way, at least for now, Curiosity still had plenty to do. And its exploration of the Red Planet was about to take an exciting turn at a spot called Yellowknife Bay. Into its mission at Gale Crater, NASA's Curiosity rover stopped to capture a breathtaking panorama. The result is this mind-blowing 1.3 billion pixel image. It's the most detailed picture ever taken from the surface of Mars. By this point, the rover had driven about 400 meters. Not a great distance, but a journey with many stops that allowed scientists to gather data about the geologic history of this unusual site. To the right lay the rising slopes of Mount Sharp, the rover's ultimate destination. But straight ahead, scientists could now see a dramatic change in scenery. Here, the gravelly terrain that the rover had been traveling on since it landed ended abruptly. Up ahead lay a more complex-looking surface, with different layers of rock exposed in the form of assorted steps and slabs. Scientists were keen to explore this location, which they called Yellowknife Bay. The name is a tribute to the capital of the Northwest Territories, a frequent jumping-off point for geologic expeditions in Canada's north. By now, they'd had a chance to zap a rock with the rover's onboard laser and scoop up some soil for analysis. But neither the rock nor the soil could tell them much about Gale Crater. That's because the rock had been blasted there by a meteorite impact, while the soil had been carried in on the wind. So to understand the hidden history of the crater, Curiosity needed some local bedrock to drill into. It began by sidling up to this intriguing outcrop, made up of thin layers of sedimentary rock. Some of the layers were at different angles, suggesting the rock was made from sediments deposited by flowing water along an undulating stream bed. After a close inspection of this outcrop, Curiosity worked its way downslope to find an underlying layer of sandstone. And beneath that, the rover found still another layer. This one was mudstone, a type of rock made of fine silt or clay that was deposited long ago, perhaps at the bottom of an ancient lake. The rock was threaded with veins of minerals that were deposited by water flowing through cracks. And in some places, Curiosity could see spherules, little round balls of minerals that precipitated out of water. Here were signs not only of rock that formed in water, but that had been exposed to water at different times in its history. And here at last was a place where curiosity could drill down to find out more. After carefully scouting the terrain, scientists chose a rock they named John Klein, after a deputy project manager with the rover mission who died in 2011. Using its robotic arm, Curiosity reached down and swiveled its drill into position. The drill punched a small hole into the rock, producing a tablespoon's worth of fine powder, which the arm delivered to the rover's onboard experiments for analysis. Unlike most of the Martian surface, the powder was gray rather than red in color. That meant the minerals inside the rock had been sealed off from the atmosphere for billions of years. Here was a rock that offered a direct connection to the past. In March 2013, 7 months after Curiosity arrived on Mars, scientists were ready to share their results. A detailed analysis showed that the minerals in the rock had formed in water that was much like fresh water on Earth, non-acidic and not very salty. Furthermore, there were chemicals in the rock that the right kind of microbes can use to drive metabolism. Curiosity had found the key ingredients that could have allowed life to flourish when there was water in Gale Crater.
For Curiosity, this was mission accomplished. While it's still not known if Mars ever harbored life, scientists can now say life was at least possible there billions of years ago.
With the discovery came the news that the rover's mission had changed. Having answered its original question, Curiosity would now try to find out where and how to search for signs of past life on Mars. By the summer of 2013, the mission reached a major turning point. After making several more follow-up measurements, scientists said goodbye to Yellowknife Bay forever and put the rover on course for Mount Sharp. The first phase of the mission was over, and there were new discoveries ahead. But before it left, Curiosity provided its own glimpse of life on Mars by using its robot arm to take this striking self-portrait at John Klein Rock. It may be a long time yet before we know if there ever really was life on Mars. But we know that Curiosity is there, and that's a terrific start.